Okay, this is our 8th grade test 9 review, and we went through, in both of my 8th grade classes today, we got through 11 or 12 of these. Excuse me. So we want to show the last 8 or so, 8 or 9. I will go through the ones that we did go through fairly quickly, and I'll be trying to move kind of fast because I don't have as much time as I'd like. But remember, you can pause the video or rewind it, anything like that. Some of these we might not even solve here because you saw them today. But let's go ahead and jump in here. Alright, and also remember, these questions are very similar to what you'll see tomorrow. So if you can understand these, you should be good to go tomorrow. Alright, one angle of an isosceles triangle is 140 degrees. What is the measure of the other two angles? That should be degrees. And that means we have a triangle like this. This would be 140 degrees, and these two have to be the same because it's an isosceles triangle. So what do? All the angles have to add up to 180. So let's do 180 minus 140, and we get, oops, jumping the gun a little bit there, we get 40. But since these two have to be the same angle, we divide this by 2, and we get 20 degrees. So 20 plus 20 is 40, plus 140 is 180. Alright, some people might wonder, why couldn't 140 be the angle that is doubled in our isosceles triangle? That's because if we have two 140s, we're over 180 degrees. So that can't be possible. Alright. Number 2, this one seems to cause a little bit of trouble for one reason, and that's because of the dollar amount that's given. So it says, to the nearest cent, what is the cost of 12.4 gallons of gas at $3 and about 19 cents per gallon? Okay, so it says to the nearest cent. Got a couple options here. You could go ahead and just do 12.4 times 3.189, okay? And then you'll get an answer, and you could just round that to the nearest cent. Some of the students today decided just to round this to $3.19. That's fine too. Get an answer rounded to the nearest cent. Either way, we should get, let me grab my calculator quick. We should get an answer that needs to be rounded to the nearest cent. So 3.19 times 12.4. So $39.556 is what we get, but we want to round it to the nearest cent. So this is 55 cents right now, but this 6 is going to tell us to round this up to $39.56. So that would be rounded to the nearest cent right there. Okay. Some of you earlier today rounded this up to $39.60. That's to the nearest 10 cents. We just want it to the nearest 1 cent. Number 3, ratios. The team's won-loss ratio was 5-4. The team played 36 games without a tie. How many games did they win? Alright, 36 represents the total number of games they played. So we want a little ratio box. Total. Lost, win, won, ratio, actual. And we got one of these going on here. Okay. Alright, kind of sloppy, but it works. Alright, won to lost is 5-4. To get a total, we just count up our column. 5 plus 4 is 9. They actually played 36 total games. A couple options here, because we are looking for how many games they actually won. Okay, so we could pull this fraction out. 5 over 9 equals x over 36. Could cross multiply divide. You could do 5 times 36 divided by 9. That would get you the right answer. Or just notice that 9 times 4 gets you to 36. So 5 times 4 will get you to 20, and you should find out they won 20 games. Either way, you should come out with the right answer. Okay, moving on. Number 4, bag contains red and blue marbles in the ratio of 3 to 4. There are 18 red marbles. How many blues are there? So, another ratio table. Red, blue, total. Ratio, actual. Another one of these. Okay, ratio tables will definitely help you set things up. There we go. Ratio, red to blue, 3 to 4. Total is 7. Says there are 18 red marbles. How many blues are there? Okay. So it looks like you could do 4 times 18 divided by 3, cross multiply divide. Or just notice that 3 times 6 gets you to 18. So 4 times 6 should get you to 24. So we should get 24 blues there. Number 5 relates to this problem. Sorry, I'm covering up my answers there. It says if we were to pull out one marble, what's the probability that the marble is blue? Okay. Now I told you earlier there's a simple way to do this. Use the ratio column because that gives you the reduced version of the fraction. Otherwise you have to go through and figure out how many blues there were and what the total amount there actually were and then find the fraction there. But they're looking at blue, okay? So how many blues were there? Or what's the probability? Should be 4/7 or 4 out of 7 chance that you will grab a blue. You could have found the actual number of blues and put it over the actual total, but it would reduce to 4/7. So there's your probability. Number 6. Write 6% as a reduced fraction and as a decimal. Alright, big thing to remember here, percents are out of 100. So 6 out of 100 reduces to, divided by 2. So reduce it to 3/50. Alright, so your fraction is 3/50. And 0.6 represents 60%. 0.06 is 6%, so 6/100ths. Another way to say that. This is in the 100th place. 6 over 100, okay? They relate to each other. So we should be at number 4 for this one. Number 7 seemed to cause a little bit of trouble, but hopefully we cleared that up today. The dimensions of a small box are 3 inches wide, 8 inches long, and 10 inches tall. What is the surface area? This formula is provided. So we have a box, and it's a 3 by 8 by 10 inch box. Not a very big box. Okay, so 8, 3, 10. Alright, so this whole problem is, it comes off of what the base is. Because we need the perimeter of the base and we need the area of the base. We're going to multiply perimeter of the base times height plus 2 times the area of the base. Otherwise we got to find the area of each part or each rectangle in this box and add them all up, and that wastes a lot of time. So, not the best here, but something like that. And our base is a rectangle, a 3 by 8 by 3 by 8 rectangle. So the top view of our base looks like this. 3, 3, 8, 8. This is our base. Okay. Perimeter of the base. We just add up all of our sides, distance around. 3 plus 8 is 11. So 11 times 2 is 22, or you can just add them all up. 3 plus 8 is 11, plus 3 is 14, plus 8 is 22. So perimeter of the base, 22. And we're going to multiply that times the height. The height of our box is 10. Okay? We add on 2 times whatever the area of the base is. Area, remember, of a rectangle is length times width. So length is 8, width is 3, 8 times 3 is 24. Okay, now we have all the pieces we need. 22 times 10 is 220, plus 2 times 24 is 48. Add these two together, and we get 268 inches squared, or square inches, okay? Because we're talking area, or surface area more particular. Okay, so remember the base is the big thing to base that question off of. No pun intended. Alright, take a look at the next one, check my time. Good chance we'll turn this into 2 parts, probably. Alright, this one. When Zena says a number, Yoli quadruples it. That means we're going to multiply it by 4. Write an equation for this. And tomorrow, you'll have to write a table with 3 pairs of numbers that'll look like this. XY chart. Okay. It'll be different numbers too. But let's say that Zena says 1. Alright, then Yoli quadruples that number, so it's 4. If she says 2, Yoli will say 8. If she says 3, Yoli will say 12. It's being quadrupled, X is, okay? So we need to come up with the equation for that. And what we have to do is, the output depends on what the input is, okay? So Yoli's number depends on whatever Zena says. Yoli's always going to have a bigger number. So we should be looking at number 1 here. Whatever Zena says, Yoli multiplies by 4, okay? So if X or Zena says 1, Yoli's number will be 4 times 1, which is 4. If Zena says 2, Yoli's number will be 4 times 2, which is 8, okay? So number 1 is the one we're looking at there. Okay. Little Pythagorean theorem question here for number 9. We went over this one today too. 2 legs in a right triangle measure 6 and 7 inches. Express the hypotenuse as an irrational number. Okay, remember the legs are attached to the right angle. Hypotenuse is the longest side or the one opposite your right angle. So let's call this 6 and 7. And we had our Pythagorean theorem, a squared plus b squared equals c squared. Hypotenuse is always c, and then a and b can interchange, it doesn't matter. So let's just call a is 6 and b is 7. Then we just plug it in. A is 6 squared, b is 7, so 7 squared equals c squared. So we just solve here. 6 squared is 6 times 6, which is 36, plus 7 times 7, which is 49, and that's going to equal c squared. 36 plus 49 is 85. That equals c squared. However, big step here, you're only one step away. C is what we want. We want regular old c, plain old c. This is c squared. The inverse of squaring something is square rooting. So square root of 85 should equal c. So we don't get a nice answer there, but we do get an irrational number, which is fine. They don't have a rhyme or a reason. They don't have any sort of pattern to them, but they are numbers nonetheless. Okay? So let's check out number 10. Check my time. Okay, we'll go over number 10 quick, and then I'm going to start a part 2 on this. This says 1/2 times x equals 2/5. Okay? 1/2 times x, we've been dealing with inverses. So what's happening to x? We're multiplying something by, or it's being multiplied by something. So in order to get rid of this 1/2, we have to divide by 1/2. So x should equal 2/5 divided by 1/2. Because 1/2 divided by 1/2 is 1. We just cross those out then, because 1x is just x. Alright, so now we go back to our division rules for fractions. 2/5, we turn it into multiplication after we take the reciprocal of that one. And we should get 3 times 2 is 4, 5 times 1 is 5. There's that one. Alright, I'm going to start part 2.